All right, well, hope you guys are doing well. What I want to talk about here today is how to multiply your rational expressions. Now, a rational expression is a certain type of expression. It's going to look something like this. We have a P over a Q. And the P and the Q, I'm taking those as being polynomials. So a rational expression function looks something like 2x plus 1 over 5x cubed plus 2. Or something else, maybe I can keep it in factored form. Maybe something like this. That's going to be a rational expression. So what I'm really avoiding here is I'm not talking about things such as square root 2x plus 1 over x plus 1. And I'm not talking about even if the square root is in your denominator. I'm not talking about this or if I have x to the minus 1. Those would not be polynomials, so it's not going to correspond to my rational function that I want to talk about. So all I want to talk about is when I have the numerator and the denominator and these fraction-looking things as polynomial up top and a polynomial down below. Okay, now the first thing is I want to multiply, or how do I multiply my rational expressions? Well, if I had something like x over x plus 2 times x squared plus 1 all over x plus 5, how do I multiply them? Well, whenever I'm multiplying these, I work these the exact same way as if I'm looking at my fractions. So the way that I multiply my rational functions, these expressions, is the same way when I'm multiplying my fractions. And you might recall, if I go back and look at something like a half, 3/5, I didn't have to do this cross multiplication because that had nothing to do with multiplying my fractions together, my expression. So if I want to multiply my fractions, I multiply numerator times the numerator and denominator times the denominator. So in this case, I get something like 3/10. And that's it. So for this one right here, what I'm going to do is multiply, well, the exact same way I did with a fraction, with the numbers. Numerator times the numerator, the denominator times the denominator. So here I would have x squared plus 1, and then x plus 2, x plus 5. And guys, that's about it. I multiply my rational expressions together, and there it is. You know, I could take this and I could expand out. I can FOIL it out, distribution property, but I gotta ask myself, what's the benefit in doing it? See, I don't always have to do that. Sometimes it's useful, sometimes it's not. See, I could take this and I could expand out, take the factor form of the polynomial, unlock it. So I have x times x squared, x times 1 gives me x cubed plus x. And down below I have x times x. I have x and 5, 2 and x, and 2 and 5. And I could rewrite it like this. It is good to get the skill set down, just refine it, make sure you're okay with the foiling process. But this tells me something about the rational expression, but this tells me a whole lot more about it. This has a bigger punch than this. So you just have to look at the problem statement and see what it's saying, see what you might need to do in a given problem. So what I want to do is look at a few problems here, run through them, and show you how they're going to work. Let's say if I have the expression 2x minus 20 all over 5x times 6 over 9x minus 15. Okay, now, when I'm multiplying my fractions, it's numerator times the numerator, denominator times the denominator. And as I do that, what I'm going to have here is I'm going to have 6, 12x minus 20, 5x, and then 9x minus 15. Now, again, guys, it's your choice. What you could possibly do, you can do this. You can say 6 times 12, 72. 6 times negative 20, 120. You could take this and expand out. But then you're going to take it and you're going to have to factor it back to simplify. So let me ask you this question. Why would you take something that's already factored, expand out, so you can have the sheer joy and pleasure of refactoring it again? That doesn't make any sense. So when I'm working through these problems, what I want to do is this, a good rule of thumb. Keep things in factored form for as long as you possibly can, until you have to unlock it and FOIL it out. Otherwise, guys, just leave it alone. So if I keep it in factored form for as long as I possibly can, it's going to make it easier. It's going to make it more manageable. It's going to save you time on exams. But hey, choice is yours. I, for one, like to do problems the easy way. I don't like to do them the hard way. So here's the easy way. I see that the 12x and the 20, there's a common factor of 4. I'm going to take it and I'm going to pull it out. Now, I also see down here there's a common factor of 3. So once again, I'm going to take it and I'm going to pull it out. Now, you might be saying, well, how come you didn't say 6 times 4? Because once again, I like to simplify as I go. And to simplify as you go means I don't want to make the problem bigger before I make it smaller. I want to keep it smaller before I make it bigger. And when I multiply numbers, do they become bigger or do they become smaller? So here, I can see a few things. I can see that the 3 is going to divide the 6. And I see there's going to be no common factor for the 4. And I see that this piece right here is going to divide out this piece right here. Now, what I'm going to do is I'm going to take this problem and I'm going to work it in probably a different way that you're accustomed to seeing. Now, the reason why I'm doing this is it's going to help out later on, especially when you start adding and subtracting irrational expressions. So instead of crossing things out, because whenever I start crossing things out, this technique known as canceling, it has major ramifications where a lot of students go astray. Now, if you look on your calculator, can you show me the canceling button? Go ahead and look. Look on your calculator and see if you can find an operation called canceling. Okay. You can see the plus sign. You'll see the minus sign. You'll see the multiplication sign and maybe a percent sign or maybe like a sign function if you have a graphing calculator or a scientific calculator. But guys, where's that canceling button at? It's not there. So why do I have an operation known as canceling, which is not really a math operator? That's kind of an interesting thought, isn't it? What I'm really doing is I'm dividing. So why do I have a different term for an operation that I already understand? I understand division, but when I use another term known as canceling, that brings up a lot of different ideas. So when I cancel something, what does that really mean? See, guys, words have meaning. It's just not some kind of word that's been floating out there. It doesn't mean anything. There's power in your words. So I don't want to go through that process, that technique, something that comes back from high school, in which I'm canceling things. Because when I cancel things, do you really, really understand what you're doing? Yeah, you can do the math maybe, but do you understand it? So what I want to do is take a little different approach. And instead of canceling things, crossing out, I'm going to push it off. Now, once again, there's a reason for my madness. Just stick with me here for a little while. Now, for the first thing is, I see there's a common factor between the 6 and the 3, so I'm going to take that and just kind of push that off, push them together. There's nothing here at the x, so I'll just leave that alone. And I'll push off the 3x minus 5. Now, again, when I'm looking at my fractions, they're division problems. So I'm really asking myself, how many times does 3 divide in 6? 2 times. And what I'm asking here is, how many times does 3x minus 5 divide into 3x minus 5? 1 time. And whenever I multiply my fractions, numerator times the numerator, denominator times my denominator. So here I would have in the very end 8 over 5x. Now, the reason for this madness, not crossing some things out, trying to learn tips and tricks in order to work your way through mathematics is, that's where usually most people fail. They try to make math into a memorization game, just a bunch of tips and tricks and formulas you have to know. That's using the wrong side of your brain. What you want to do is use the left side of your brain, the side that has analytical thought processing skills. And that's what I'm trying to do here today. Help you develop those skills so you can go further in your education, so you can actually get that dream job you're trying to get. So here, I have 1. And again, this is going to come up again when I'm adding up fractions. You're going to see this 1 that pops up again. Okay, well, let's look at another problem. Let's say if I have a squared minus 1 all over 4a times 2, 1 minus a. Now, once again, what I want to do is I want to multiply the numerator times the numerator and the denominator times the denominator. And here, as I go about the problem, I'll have 2x squared minus 1, 4a, 1 minus a. And notice how I'm not expanding out. I want to keep things in factored form for as long as I possibly can. So I'm not going to say 2a squared minus 2, because then I have to go back and factor it again. That's just wasting time. So the next step here is I want to factor. And notice what we have. We have a square, and we got a difference. So what property is this? If I have a square minus a square. You think it's the hippopotamus property? No. It's the difference of squares property. And remember, if I have a squared minus b squared, that's a minus b, a plus b. That's the property that I want to use. A minus 1, a plus 1. Now, notice how this piece right there, it's so incredibly close, that piece right there. So in these kind of situations, when it's so incredibly close like this, here's what I do. I see there's just a difference in a sign. So I take the sign, the negative, and I factor it out. Now, I can factor it out in the numerator, the denominator. It doesn't really matter. Just make sure it gets factored. And there it is. -1 times a gives me back to negative a. And a -1 times -1 gets me back to positive 1. And what I want to do again is I want to avoid crossing things out. I want to break that habit. I want to make sure that I'm actually going through the math the right way. So I'm setting myself up for success and not for failure down the road. So what I want to do is I just want to push some terms off. I have the a minus 1. I see it down below. I'm going to take it and push it off. A minus 1, a minus 1. And I also see there's a common factor with a 2 and the 4. So I'm going to take that and also just push that off. Now the negative, I'm going to keep that locked in with a little a. And then what's left over is the a plus 1. Okay, so go ahead and take a moment and see if this is making sense to you. Once again, I'm not crossing things off because I'm trying to get away from those bad habits that we're so accustomed to in high school that's causes problems later on in our math classes. I just want to simply push off common factors. And by pushing off the common factors, it's going to help out later on when we're adding and subtracting our rational expressions. So a minus 1 over a minus 1 is 1. 2 over 4, that's a half. Now, the negative sign, I can write this in different ways, guys. I can put the negative out front like this. That's okay. Or I could keep the negative sign down below. That's okay. Or I could go ahead and just simply absorb it into the numerator. That's okay. So I have these 3 different ways of how I can write it, if I need to, or if I want to. And notice how it's going to be 1 times a half times this, which in the end is going to be negative a plus 1. Keep it locked in the side parentheses over 2a. And there's my answer. And again, what's saying, you can take that negative and you could absorb it down below. But there it is. Okay, so take a moment and see if this really, really makes sense. Okay, so let's look at something a little bit more complex now. Suppose if I have x squared minus 25 all over x squared plus x minus 20 all times x squared plus 7x plus 12 all over x squared minus 2x minus 15. And what I want to do is I want to take this and I want to multiply out and simplify the results. So I guess what that means here is I'm going to say x times x squared, which gives me my x to the 4th. And then I can say x times the 7. And I could say this, and I could keep going along as I go about this problem just like this, but notice how complicated it's starting to become. I have a degree 4 polynomial. I have to simplify the results in the very end. That's going to require me to factor the polynomial. Can you factor a degree 4 polynomial? Well, not yet, but do you see how hard that is? So when I'm working through these problems, that's probably telling me, don't do this. So I don't want to do that. That's not the right way of going about the problem. Now, remember again, the whole entire adage, simplify as you go. Let's not make the problem more complex than it needs to be. It's a fraction, rational function, times another one. Numerator times numerator, denominator times denominator. So what I'll have here is simply x squared minus 25, x squared plus 7x plus 12, all over x squared plus x minus 20, x squared minus 2x minus 15. Now, the next thing is I want to factor. I want to factor each and every one of these pieces. So I want to factor the x squared minus 25. Guys, that's your difference of squares identity again. That's going to factor as x minus 5, x plus 5. Then I want to factor this piece here. So the x squared plus 7x plus 12. So think about the factors for 12, which will sum up to 7. 4 and a 3. Okay, there's that piece right there. And then here, I'll have factors for negative 20, which sums up the value of 1. A 5 and a negative 4 will do the trick. And this piece here, I'll have x. Now I have negative 15. So I'm looking at probably a 3 and a 5. It is a negative 2, so it's probably a negative 5 and a positive 3. Now, the next thing is, I don't want to take this and expand out again. I still want to simplify it. So what I'm going to do is I'm going to push off the terms. Again, I'm avoiding that bad habit that we learned so well back in high school called canceling. If it's on top, if it's down below, then it's got to go. What I'm trying to do again is I'm trying to break you away from those habits so you can be successful in your other studies as we go further through the course. So the first thing is I do see a common factor of x plus 5. So all I'm going to do is just push it off. Okay, so it takes care of this piece. I'll say common factor of x minus 5. So I'm going to take that in, push that off also. Okay, so that piece taken care of, that's taken care of. Now see there's an x plus 3. So when I take that and push that all off as well. And what's left over is the x plus 4 and the x minus 4. Now, doing it like this, I see that this goes to 1, that goes to 1, and that goes to 1. And again, the reason why I'm doing this is to help you when we start adding up fractions. Lots of times students will say, well, how do I add up fractions? These rational functions. You got to get a common denominator. How do you do that? It's just a reverse process of this right here. So that's 1, 1, 1, x plus 4, x minus 4. X plus 4, x minus 4, there's your answer. Okay, now take a moment, go back and review it, and see if it makes sense to you guys. Okay, so let's consider this one, in which I'm taking this rational expression, I'm multiplied by this rational expression. And again, what I want to do is I want to simplify as I go about the problem. So what that would entail is I want to factor this. I want to factor the numerators and my denominators. I don't want to take this and expand out. way too complicated, way too hard. They'll get me a degree 4 polynomial. I don't want to factor a degree 4 polynomial. Again, it's really complicated. So let's simplify as we go, and we can bake into the process the simplification that we need to do. Okay, so for the first piece here, t squared minus 49, that's going to correspond to my difference of squares. For the 49, I could express that as 7 squared. So here I'll have t minus 7, t plus 7. And again, I'll leave the factor for 21 or negative 21 with sums of 4. And I say it's going to be something like t plus 7 and t minus 3. 7 plus negative 3, positive 4. Okay, try the next one. T squared plus 8t plus 15. And then down below, I can do something real similar also. Maybe something like t minus 7, t plus 5. Because 5 times negative 7 is negative 35. Negative 7 plus 5 is negative 2. Now, what I'm going to do again is when I multiply through, it's a numerator times the numerator and the denominator times the denominator. And I'm avoiding the technique, the misguided technique known as cancelization or canceling terms. I don't want to start crossing things out. What I want to do is understand how this is working so I'm not causing any obstacles to form in my education. So what I'm going to do is pull out the common terms. And I do see a common term here at t minus 7. So I'm going to pull it out. Okay, and t plus 7, I see one down here also. And t plus 3, t minus 3, nothing's being played out there, but the t plus 5 is. And then everything that's not in common, I'll push it over here. So I have the t plus 3 and t minus 3. So again, a fraction is really talking about a division problem. So how many times is t minus 7 divided by t minus 7? Once. T plus 7 divides into t plus 7 once. And here divides into it once. What remains is t plus 3 and t minus 3. So when I simplify, I don't want to take this and expand out. Way too challenging, guys. Keep things in factor form for as long as you possibly can. And notice, it's pretty much already in factored form. So don't expand out, just keep factoring it all the way. In the end, we'll have t plus 3 and t minus 3. Now, you might say, don't the t's cross out? No, because once again, this technique known as canceling, it's really called division. And I can't take the t's and I can't divide them out because the plus sign, the minus sign is like a gear in the clockwork. It's just not allowing me to go forward. Okay. Well, let's look at one more problem here. And let's look at this one. Let's say I have b to the third minus b to the third. We have our a squared, b squared, 2a, 2b, 2a, plus 2b. Now, again, I just can't come through here and cross things out. That's not how math works. So what do I need to do? I need to divide terms out. To divide terms out requires me to factor the terms to begin with. And I do have this piece factored in a sense with this piece, But I do have this issue right there of a division sign. So how do I work rational equations, or these expressions which have division signs in them? How do I take something that says a over b when divided by c over d? How does that really work? Well, let's go back. Look at an easier problem. Let's see if I have 6 divided by 3. What does that mean? It means 6 divided by 3. So I can write it in terms of a fraction. So I can take this, and I can write it in terms of a fraction. Now, the question is, how do I work through these kind of problems? I have a fraction divided by a fraction. Well, what comes into focus now, what comes into play, is that skill set we've been working on of pushing off common factors to get a value of 1. Here's what I can do. I can multiply this expression by d over c and d over c. Because now I can multiply by whatever I want. Numerator and denominator are the same, so this is another way of saying 1. Like the t plus 5 over the t plus 5. That's 1. Well, multiply the numerator with the denominator. And guys, look at this. What's that? It's 1. How many times does DC divide into DC? Once. So what I have here then is if I have A over B divided by C over D, this is going to reduce down to A over B, D over C. What I have here is commonly referred to as a keep the fraction. Then I want to change. I want to change the sign from a division into a multiplication. And then this right here, I flip it. So I have a keep, change, flip. So when I see division problems like this, I take the fraction and I flip it. Look at the reciprocal. So for this given problem, I'm going to turn the division into a multiplication. I'm just going to flip it. 2a plus 2b, 2a minus 2b. Okay, and as soon as I have my multiplication problem, we're good to go. So these kind of problems just adds just one extra layer when I'm solving my products, multiplying my rational functions. Okay, so let's go ahead and go through this. Here I have a difference of cubes. So I apply the difference of cubes identity. Okay, this is something we need to know. And remember, keep the sign, flip it. And this right here is going to be an irreducible quadratic. I won't be able to factor this anymore. But here I have a difference of squares. And here I can factor out a 2. Okay, and what I want to do again is I just want to push everything off as a common term. A minus B, A plus B. And this thing here with 2, we'll push that off also. And what I'm left with is an A squared, AB, B squared over A minus B. And of course, this will divide out to 1, as well as this piece and this piece. So in the very, very end, there's our answer. Okay, now let's put into practice what we just learned. What I want you to do for the next few minutes is I want you to work through these problems. Go ahead and multiply them, divide them, do whatever the operator is telling you to do. And you're going to take these problems and you're going to upload them later on so I can see what you're doing. So I can make sure you're on track and you're doing okay with your studies. And if you're having problems working through these, let me know. Let's set some time later on this week and let's discuss them. Let's make sure you're staying on track and you're not sliding behind. Okay, well, if you need anything, just let me know. Other than that, you guys have a great day.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.